Okay, now we're going to do notes over parabolas. Parabolas are another conic section, and they're the set of all points in a plane equidistant from a point called the focus and a line called the directrix. So in Algebra 1 and 2, you learn different forms of how to write the equation of a parabola. You learned we called it standard form, but this is really general form. And when you had it in that form, the A value told you how wide or narrow the parabola was. It told you it also told you if it was opening up or down. The C told you the y-intercept. So that form was pretty helpful for those things. We also learned about the factored form. And the factored form, it told us, the A value told us the same thing. It told us whether it opened up or down, how wide or narrow it was. The R's told us the x-intercepts for the parabola. That's in factored form. The vertex form, the A value does the same thing as it does in the other forms. And then you've got HK, which tells you the vertex. So those three forms were helpful in their own ways. Now we're going to learn another form, which is the standard form for conic sections. And they look like this. This is the way the equations look. We're introducing a new thing where we've got a y that's squared. So now we're looking at when it opens right or left. And so when the y is squared, it opens right or left. And when the x is squared, it opens up or down. The h and the k will still tell you the vertex. Your axis of symmetry, if you're opening either right or left, your axis of symmetry is a horizontal line. If you open up or down, your axis of symmetry is a vertical line. And we'll talk about the focus and the directrix as we move on. So now let's look at some pictures of these. So when your x is squared, you're going to write the equation where the variable that's squared is on a side by itself, and then you've got this thing called 4p right here, and then times the y minus the k. Again, you only have one variable that's squared on a parabola. So in this picture, you've got your axis of symmetry right here. It's dividing the parabola into two equal parts, basically. Then you've got this directrix. The directrix is right here. You've got a point called the focus. The focus is right here. So from the vertex, which is right here, let me see, sorry. The focus and the vertex are exactly p units apart from each other. The directrix and the vertex are also p units apart from each other. So the length from the focus to the directrix is 2p. Again, if it opens, and also notice that the focus is, if this is your vertex, your focus is above the vertex if it's opening up. If it's opening down, the focus is below the vertex. And again, it's going to be p units away from the vertex. The directrix will be p units on the other side of the vertex. Your axis of symmetry is drawn like this, and your directrix is perpendicular to that axis of symmetry. All right, on the next one, when it opens right, here's your vertex. Your focus is to the right of the vertex if it's opening right, and it will be p units away from the vertex. The directrix will be p units away on the other side. Here's your axis of symmetry for the parabola. Your directrix will be perpendicular to that axis of symmetry. If your parabola opens left, here's your vertex. Your focus will be to the left of the vertex. It will be p units away, and your directrix will be p units away on the other side. Your axis of symmetry is here, so your directrix will be perpendicular to that axis of symmetry. And you can get that p value by whatever number's been factored out from this right here. Notice this x has a 1 right here. Whatever number's attached to that x has to be factored out, and that will help you get your 4p. All right, let's do some examples. Okay, on this example, we were given this equation right here. Notice that the y is squared, so we're using this form right here. If the y is squared, that tells me automatically that this parabola is either opening left or it's opening right, which means that I'll have a horizontal axis of symmetry. So it will be a horizontal parabola. The vertex here, I have nothing that's being added to the x or the y, so my vertex is at 0, 0, which means I'm going to go ahead and plot that right there. That 12 that's in front of my, let me erase this right here, sorry. That 12 that's in front of the x right there, that's my 4p. So 4p equals 12, which means that p equals 3 when I divide that by 4. So that's going to help me, because the p is a positive number, that tells me that it's going to go right. I already narrowed it down to either left or right. The fact that p is positive tells me that it's going right. So I'm going to have a parabola that looks like this. There is my vertex. My focus, because it's opening right, has to be to the right of the vertex, and it's got to be to the right p units. So I've already graphed my vertex over here. I'm going to go to the right 3 units to graph my focus. And then 3 units to the left will be my directrix, and it's got to be perpendicular to my axis of symmetry, so it's going to be a vertical line there. And that's at the equation x equals -3. Remember, any vertical line has an x equals equation. My focus was the ordered pair 3, 0. All right, now then we've got another segment called the lattice rectum. The lattice rectum is always 4p units long, so this one will be 12 units. And what you're going to do is you're going to graph 6 units, half of it, on each side of the focus. So over here at 3, 0 is my focus. I'm going to go 6 units up, which puts me right here, and then 6 units down, which puts me down here. And those are 2 more points on this parabola. So that gives me points for me to help me graph this parabola. So this little segment right here, that's the lattice rectum, and it's 12 units long. 6 of it is on one side of the focus and 6 units is on the other side of the focus. So the endpoints of that lattice rectum are 3, 6 and 3, -6. All right, let's do another example. Okay, on this example, we have the equation in general form, so we've got to get it in standard form. My x is what is squared, so that's going to be on a side by itself. So we're going to do x squared minus 6x plus some number. I'm going to have to complete the square so I can factor it. Remember the the standard form looks like this. So I need to move the 8y and the 1 over to the other side. So that 8 becomes positive and that 1 becomes negative. And then whatever I'm adding to this left side, I also have to add to the right side to balance the equation. And then what I'm going to be adding to both sides, I take that -6, I divide it by 2 and square it, so I'll be adding 9 to both sides. So now that will, on the left-hand side, that's going to factor to be x minus 3 squared equals, this is now 8y plus 8. Now remember, I need to know what my 4p is. I have to factor out whatever number is attached to that y. Even if the other number on that right-hand side isn't divisible by that number, you still factor out that number attached to the y. So that's 8, and then this becomes y plus 1. So now I know what my vertex is. It's going to be at, remember the x value of the vertex is with the x factor, so that's going to be 3. The y is -1. The fact that the x is squared tells me that this one opens up or opens down, which tells me it's vertical. This 8 right here, that's my 4p. So 4p equals 8, which means p equals 2. And because p is positive, when p is positive, it opens up. When p is negative, it opens down. So this one's going to open up. So let's graph that vertex. It's at 3, -1. I know my graph is going to go up, which means my focus has to be above the vertex, p units. So I'm going to go from the vertex up p units to get my focus. My directrix will be 2 units on the other side, so it's going to be right here. It has to be perpendicular to my axis of symmetry, that's my axis of symmetry, so my directrix has to be perpendicular to that. Okay, so my focus is at 3, 1, and my directrix is at the equation y equals 3. It's a horizontal line, y equals -3. It's a horizontal line, so it's a y equals equation. All right, now my lattice rectum, it's going to be 8 units long because that's what 4p is, and so I'm going to go half of that on each side of the focus. So I'll go 4 to the right. Oops. Right there is one endpoint. And there's the other endpoint. So this is my parabola graph. So those endpoints are at -1, 1, and 7, 1. And that's it for that one. Okay, on this last example, they gave me the focus is at 4, 0. So I'll plot that first. And my vertex is at 4, 3. So my vertex is like this, and my focus is below it, which tells me that this parabola opens down. I know that the distance between my focus and my vertex is 3 units. That means P equals a -3 because it's opening down. So 4P is going to be a -12. So when I write my equation, because it opens down, I know my x is squared, so it's going to be in this form. X minus h squared equals 4P times y minus k. And I know my vertex is at 4, 3, so I'm going to do x minus 4 squared equals, our 4P is -12, and then x minus 4. Oops, I'm sorry. Let me back that up. This should be y minus 3. Sorry about that. Okay, so that's the equation for this parabola. All right, that's it for these notes. Thanks, y'all.